This video will be on section 8.1, complex numbers. So the topics in here, we'll first talk about the number I and what a complex number is. Then we'll look at simplifying complex numbers. Then we'll add and subtract complex numbers. And finally, how to multiply complex numbers. You'll notice we don't have division of complex numbers here. Some of you may have learned how to divide complex numbers, but it is not a topic we need to cover in this class. All right, so first thing, the definition of I and what a complex number is. All right, so I is the imaginary number that equals the following. So recall that if we had the negative number under a square root, we said that wasn't a real number. Well, what we do is we call I to be the square root of -1. So this is really what I is. Very often you'll want to know what I squared is as well, because when we get to complex numbers, we actually will be able to simplify something that has a I squared in it. And I squared equals -1. If you wanted to see how to go from the first line to the second line here, why are these the same? You could square each side of the equation. All right, but you definitely want to remember the top one the most. If you're studying for the test and you only have room in your brain for one of these two equations, remember that I is the square root of -1 because you can square each side to get back here. All right, so a complex number is written as a plus bi, where a and b are real numbers. You don't have to know this definition, but I just like to point it out anyway because I might use it in the video. A is called the real part because it's not multiplied by an I, and B is called the imaginary part because B is multiplied by the I. The reason we use the letter I is for imaginary. As an example of a complex number, we'll see plenty below, but 3 plus 4i is a simplified complex number. All right, we'll see below when things aren't simplified and how to simplify them. But when you're looking to simplify a complex number, your goal is to have a part without I and a part with I. You might not have both parts, so we might only have, the 3 here, which would make it a real number. But you might also only have the 4i part. You don't have to have both parts, but this is as much as it can be. You won't have an I squared or any other higher power of I. We don't have any fractions, meaning we don't have a I on the bottom of a fraction, and we do not have any multiplications or exponents here. Right, so that's kind of what I mentioned here. The important thing about complex numbers is they can always be simplified to the form a plus bi, no matter how messy they look. And that's really all this section is about, simplifying, getting comfortable with simplifying complex numbers. Right, and we'll have a few examples here talking about what it means to simplify them. So when we're doing this, what we're trying to do is make all the examples that I have here below look like a plus bi. No negative square roots are allowed to remain, no multiplications, no divisions, nothing like that. All right, so number 1 here is the square root of -180. Now, anytime you see a negative in a square root from going forward in this class, that means that there is an imaginary number. But what you want to do anytime you see a negative square root is the following. We want to break this up as -1 times 180. So no matter if you have a negative number here, break it up as -1 times that number, just like that. So we got the square root of -1 times 180. And the reason we can do that, or we want to do that, is now we can break up multiplications over square roots. So that you can do that with multiplication or division. This time we have multiplication. If you had addition, that would not work, or subtraction. All right, so what I mean by break it up is we can do the square root of -1 times the square root of 180. And now the reason why we like to break it up like that is the square root of -1. This is what we called I. And we can't simplify this, but we'll just leave it alone for a second. The square root of -180. The one thing I think this part's going to teach, anytime you have a negative number in a square root, you can get rid of the negative sign as long as it becomes an I on the outside. So you don't have to go through all these steps if you remember that, but it's not a bad idea to practice these steps. Right, so very literally, if I went from this part here, square root of -180, to this, I times square root of 180, it looks like I exchanged the negative inside with the I outside. And that's pretty much what I did. Right, but now that we've got the I out there, we have a positive number inside, 180. Now we just want to simplify this square root. All right, so remember, to simplify square roots, we're looking for perfect squares inside 180. And 180 happens to be 36 times 5. All right, so remember, one thing you can do to do this is you want to find the biggest perfect square. We would not worry about 1, so we could do 180 divided by 4, which is 45. Now, that's helpful. We could write 180 as 45 times 4, but I want to go see if there's a bigger perfect square. So we could do 180 divided by 9. Well, that's another perfect square. We could say 180 is 9 times 120, but maybe we can go even bigger. 180 divided by 16. That doesn't work, but that doesn't mean it's the end of the line. The next perfect square is 25, because that's 5 times 5. Still doesn't work. 180 divided by 36 is 5. And now the reason why I know I can stop there, 180 equals 36 times 5, is because 5 has no perfect squares in it. Right? The ones above, when we had what divided by 9, for example, when we had 20 left, there's still a perfect square of 4 inside. Right, but that's just a brief reminder of that. Remember the way we deal with this now. We got I times the square root of 36 times 5. So it looks a lot like what we did with the negative before. Then the reason we want to find the perfect squares, we break up over the multiplication again, just like we did with the -1 back here. And we can simplify the square root of 36 to 6. Right, and the way I have it written isn't wrong at all. Some people like to rearrange it. Some people like the I in the front, which is fine. I prefer to put the I in front of the radicals, but behind whole numbers. You can also throw it in the very back, meaning you can do 6 times square root of 5 times I. One thing I will warn you on this, doing it right like this, is if you put the I at the end, you run the risk of accidentally putting it inside the square root, which it is not. So do not put the I inside the square root. Okay, but all three of these last ones are correct. The only square root that's left is having 5 inside, and that cannot be simplified. You just choose whichever one you're most comfortable with and do it like that. All right, so number 2, we got 6i times 5i. The reason this is not simplified is because there's multiplication. Now this is not really multiplication of complex numbers in the way we'll do it next. This is a little bit shorter. The way you want to think about how do I multiply this? What would you say this, what would you do if this was 6x times 5x? Well, this isn't the actual problem, but we know to multiply this, we would do 6 times 5 is 30, x times x is x squared, and that would be our answer. You do the same exact thing when you have I. So 6 times 5 is 30, I times I is I squared. The very important thing about complex numbers is you never want a power of I, except 1. But we can simplify this because I squared is -1. All right, that's one of the 2 ways we like to think about it above. I squared is -1. Never leave an I squared in the answer. All right, so let's go ahead and plug that in. We got 30 times -1, which is -30. And that's it. Now you saw from these first 2 here, so this one is a complex number, but it did not have, this is like our b in a plus bi form. A was 0 because b is what's multiplied by the I. This is also a complex number, even though it's a real number. It just happens to be that a is -30, because there's no I left, and b happens to be 0. And that's okay. All right, so the last one I got right in this little section here is, it looks a lot more complicated, but it's going to be the kind of things we're simplifying next section a lot. And what you want to do if you see something like this, anytime you have a square root, really it's a good idea to try to simplify the square root first. And just think about how we did number 1 above. How do we want to simplify that? So I'm going to do this on the side and then plug it back in. Square root of -2, 32 rather. As we mentioned before, the negative comes out as an I. So it's I times the square root of 32. And then we want to get a perfect square from 32. And 32 equals 16 times 2. 2 is a prime number. It doesn't have a perfect square in it. So we're going to fill that in. We got I times the square root of 16 times the square root of 2. And the square root of 16 is 4. So we get I times 4 times the square root of 2, and whichever way you like to write it. So if you want to put the I in the middle, if you want to put the I in the back, use either one of these 3. All right, but what I'm going to do is I'm going to plug in, I like the middle one. That's just the way I'm used to it. So I'm going to plug it in. And not reuse that color. And then I'm just going to give myself the space and plug it in over here. So we got -8 plus 4 times I times the square root of 2 in place of our negative square root of -32 all over 6. Now what we want to do is split up the fraction because we want a plus bi form, which means if we have fractions, we can have a fraction in each part, but not on the whole thing. So we want to split up the fraction. meaning we're going to put the -8, the thing in front, over 6, and then plus the thing in back, 4 times I times the square root of 2 over 6. Now, if you want to think why this makes sense, why can we do this? Imagine we were starting with this over here and we wanted to combine the fractions into one. Well, we have a common denominator, so we would get exactly this. But now once you are here, simplify each fraction and you're done. Right, so the one on the left here, a little bit easier to deal with. We can take a 2 out of each. We get -4 on top and 3 on the bottom. And the one on the left here, one thing you want to do, you can never cancel something in a square root that's with something not in a square root. So let me write a major note here. You probably know this, but maybe it's been a while since you've dealt with square roots. Never cancel a number inside a square root with one not in a square root. Right, meaning I can't cancel this 2 out with a 6, the 2 is stuck inside, but I can take a 2 out of the 4 and 6 each, and I get 2 and 3 respectively. So on the top here I got 2 times I times square root of 2, and on the bottom I have 3. And this is in a plus bi form. If you're a little bit bothered because of the second part, the I is not in the back, you could just move this I back here. B is 2 times the square root of 2 over 3. A happens to be -4/3. Right, but simplifying this, think about what we did. Take the square root, simplify it, split up the fraction, and then simplify each fraction. That's it. When we go into next section with the quadratic formula, when we use quadratic formula, our answers are often going to look like this, and we need to simplify them. So you've got to be able to do this step. Right, now, addition and subtraction of complex numbers is pretty straightforward. If you think about I being x, you would and ask yourself, how would you simplify this? And that's going to be it. So it says evaluate the following expressions and write the result in a plus bi form. Right, and as I have written up here, to add or subtract two complex numbers, it is very similar to combining like terms. Often, it is helpful to think of I as x when you begin simplifying these. So here we've got 2 minus 6i plus -8 minus 7i. One thing I want to mention for this one is the parentheses are not needed because we would only be distributing a 1 through each. So let's just go ahead and get rid of them. The reason the problems are often written like this is to separate what looks like two complex numbers. But just get rid of them because distributing a 1 doesn't do anything. We got 2 minus 6i plus -8, so I'm just going to write -8 plus -7i minus 7i. And, once again, think about combining like terms. We would combine the 2 with the -8 because they don't have I. And we would combine the -6i with the -7i because they both have I, just as if they both had x. And when we do that, 2 minus 8 is -6, minus -6i minus 7i is -13i. And whether you believe it or not, that's it to this problem. That's all there is to do there. Subtraction is much the same way. You just have to be careful about subtraction because you do have a minus sign here. So you got to be careful to distribute. So don't forget to distribute the minus sign. But outside of that, it's going to be exactly the same. So we got 2 plus I. Right? We only have like a 1 in front here, so we can get rid of the parentheses. Then we distribute the negative sign to 7, we get minus 7. Distribute the negative sign to negative 6i, we get plus 6i. And same deal, combine your like terms. I'll just underline them again to emphasize what we're doing. We're combining our like terms. And for the things without I, we got 2 minus 7 is negative 5. And the things with I, we got I plus 6i is 7i. And that is it. Notice that these are both in a plus bi form. This one here, a is negative 6 and b is negative 13. This one here, a is negative 5 and b is 7. All right. Now, when we do multiplication, it's really similar to just foiling numbers. Since we kind of multiplied 2 before, one thing that you'll definitely have to remember is you will always get an I squared in your answer, but you need to get rid of it. You will have to use I squared equals negative 1. All right, so once again, when we see the problems, the reason it's going to look a lot like FOIL is just think of what you would do if there was X instead of I. Right, so we've got perform the indicated operation and simplify. Express the answer as a complex number a plus bi. But we know this means to multiply because there's not, plus or minus sign here, just like we would normally, right? We want to FOIL this. So we got 11 times negative 4 is negative 44. 11 times negative 5i is negative 55i. Negative 8 times negative 8i times negative 4 is positive 32i. And negative 8i times negative 5i is positive 40i squared. Right, that's similar, this part that's similar from before. Right, so just in case you lose track of where we got the I squared from, it's because we multiplied these two things that both have I in them. Now this is what I always do first, is replace I squared with negative 1. The reason why I like to do it first is it's the easiest thing to kind of forget because you think about combining like terms and then you don't see anything in common with I squared. It's easiest to forget. So I got negative 44 minus 55i plus 32i and then plus 40 times negative 1. And if you want to do one more step, you might be able to simplify it from here already, but I'm just going to multiply that negative 1 and then we'll see what to do. Right, so 40 times negative 1 is negative 40. Now think about exactly what we were doing above. We want to get a plus bi form. We just combine like terms. We have no I squareds. We'll be done after this. All right, so we got negative 44 and negative 40 make negative 84. And then negative 55i plus 32i is negative 23i. And that is our final answer. This is a plus bi form. A happens to be negative 84. B happens to be negative 23. All right, now the last one really is just, I always like to go over problems like this because especially when you have something new, you might think you do it differently. But when we square something, that means multiply it by itself. There's not a special rule because we have I. If you just square each part, you will absolutely 100% get it wrong. So we multiply it by itself, we got 7 plus 12i times 7 plus 12i. And then FOIL it out now. We're in the position just like the above problem, we can FOIL it out. 7 times 7 is 49, plus 7 times 12i is 84i, plus 12i times 7 is also 84i, plus 12i times 12i is 144i squared. Right. Immediately do what I said above, because it's the easiest thing to forget is plug in -1 for I squared. So we got 49 plus 84i plus 84i. And then when we plug in our -1, it becomes a minus 144, just like above. When we plug in the -1, it just boils down to changing the sign, we multiply it. And now we combine our like terms to finish. We got 49 minus 144 is -95. And 84i plus 84i is 168i. And this is in a plus bi form. A is -95, b is 168. We are done. And really that is what we need to know about complex numbers for now.